Okay, so this is a presentation about the ionization of water. So the equilibrium process, self-ionization of water is a process in which water ionizes to hydronium ions and hydroxide ions. So water basically splits up into its two ions, H being the positive, hydrogen being the positive one, and hydroxide being the negative one. And like the first equation is probably the easiest to remember and like the simplest to comprehend. And yeah, so water basically just breaks up into its individual ions. And the equilibrium position strongly favors the reactant water molecule. The ion product constant is the ion product of water and is also known as Kw. It's the mathematical product of the concentrations of hydrogen ions and hydroxide ions. So Kw is equal to H plus times OH negative. The value of K is very small, and it's consistent with a reaction that heavily favors the reactants, just like what we talked about in the last slide with the equilibrium process. So K is equal to 1.0 times 10 to the negative 14th. So yeah, it's very, very small. The hydrogen ion is equal to 1.0 times 10 to the negative 7th, and that is also OH because if you times those together, then you would get KW, and that's KW's hydrogen times hydroxide. So for a practice problem, the steps you need to do is, so you have to list the unknown and the known substances. Number 2, set up the equation. 3, solve for the unknown substance. So in the next slide, I'll show a practice problem that will help. So the question is, a certain aqueous solution has a hydroxide ion concentration of 5.8 times 10 to the negative 4 molarity. Calculate hydrogen in this solution. So this is my work for the problem that I did. So step 1, find the known and unknown. So the known, we know that the hydroxide ion is 5.8 times 10 to the negative 4, and that is shown in the known, under the known. And then Kw is the constant, and that's the 1.0 times 10 to the negative 14th. And then our unknown is the hydrogen, and so we just leave that as a variable, or just like a question mark. So for steps 2 and 3, we set up our equation, so that would just be the Kw equation. So Kw is equal to hydroxide times hydrogen. So we plug in our values that we have, the known values, and we have Kw, so we put the 1.0 times 10 to the negative 14 on the left side, and then on the right, on the other side of the equal sign, we put our hydroxide concentration, which is 5.8 times 10 to the negative 4, and then times our variable, which is the hydrogen, and then we solve for the hydrogen. So you would divide Kw by your hydroxide concentration, and that equals 1.7 times 10 to the negative 11th. So yeah, that's a practice problem. So hydrogen ion concentrations can be neutral, acidic, or basic. So neutral is when any aqueous solution in which hydrogen equals hydroxide, and therefore the concentration of hydrogen will be the same as hydroxide. So practically they're just the same. So hence the name, the word neutral. But for acidic and basic, it's different. So as for acidic solution, the concentration of hydrogen ions are greater than the concentration of hydroxide ions. So if you had like an ion, the hydrogen would be the concentration would of the hydrogen would be greater than the hydroxide. And then for the basic solutions, it would be the opposite of that. So the hydrogen ions would have a lesser concentration than the hydroxide ions. So yeah, that's it for my presentation. Hope you learned something.